Hey, my name's Ed Barrett Leonard, and I'm doing a series of talks on things that you can do with salt-affected land, growing plants on salt-affected land, and this first talk is going to be a general introduction to the overall series of talks that I'm going to do. Okay? Let's get into the slides. Okay. In this introduction, I want to give you a sense of an overview to dryland salinity in southern Australia and the opportunities that there are to grow salt-tolerant pastures on much of this salt-affected land. I think we all know what salt land's about. We've got a feeling for it. It's about increases in soil salinity and waterlogging, decreasing plant growth, and the solutions are about hydrology, and they're about drainage and surface water management, and the growth of better adapted plants. And of course, a better understanding of animal tolerances to salinity. But mostly, salinity solutions are about people. And that's of course why we're doing this series of presentations. And as Warren Mason, the former national coordinator for SGSL, would say, that's bloody right. It's about people. I think saline agriculture is one of Australia's great environmental hope stories. Scenes like this, which is a Puxnelia stand in South Australia, or this, the saltbush stand in Western Australia, or this, another saltbush stand in New South Wales. These are the sorts of scenes that give farmers hope about what's possible on salt-affected land. How did we get here? Well, it's now 2010, and we are halfway through the Future Farm Industries Cooperative Research Centre. In the 1950s to the 1970s, the work that we're doing now was really built on the foundation of people like Clive Malcolm and Dennis West, who worked in state government departments of agriculture. In the 1990s, this work was further built on through the PURSL network. PURSL stands for the Productive Use and Rehabilitation of Saline Land. This was a group of people from different states who all got together because we believed that the solutions weren't confined to states but crossed state boundaries. And this work was supported by the National Dryland Salinity Program. And then early in the noughties, the Animal Production on Saline Land Systems program established to start doing work on a national basis in saltland pastures, and this was then adopted into the CRC Dryland Salinity in the SGSL program. SGSL stands for Sustainable Grazing on Saline Lands. And there were a couple of projects, screening plants for salt and waterlogging tolerance in CRC Salinity, and also another project on salty diets. And there were a range of PhD projects also in the CRC. And all of that has been the foundation on which the sorts of things that we're talking about today is now built. I think many people watching this will come from WA, and in Western Australia, if you stand on the side of a river and look across it, you may well see a scene that looks like this, or on the edge of a lake and look across it, you may well see a scene that looks like this, or on a piece of degraded farmland and look across that, you may see a scene like this. And we can estimate the percentages of farms salt affected in Western Australia using the Land Monitor data set. We know the areas of farms, and we know where the areas of severe salinity are. You can see it in red there. And we can calculate what that area of salinity is as a percentage of the total farm area in a GPS, and then map the results of that. And that's what this map looks like for Western Australia. This is a map of the proportion of wheatbelt properties affected by salinity. And you zoom into an area like that, and you can see that we have some farms in Western Australia that are 30 to 50% salt affected. But the thing that I get from this is that salinity is not democratic. Not everyone gets an equal share. Most farms in Western Australia have less than 10% of the farm salt affected, but some farmers are acutely affected. And for those farmers that are acutely affected, salinity is a real issue. How do they feel about it? Well, they don't feel very flash about it, actually. But I think that the work that we've been doing in the development of productive uses for salt-affected land can really change this. We now know a lot about the cause of landscape salinisation in Western Australia, and in fact across the whole of Southern Australia. And the groundwork was laid by this guy, W.E. Wood, and he published a paper in 1924 called The Increase of Salt in Soil and Streams Following the Destruction of the Native Vegetation. It was published in the Proceedings of the Journal of the Royal Society of WA. And this, Wood was a railway engineer, and he was really concerned about the development of salinity in dams in Western Australia, because they were putting salty water into railway boilers, railway engine boilers, and they were cankering up. And it was an extremely difficult process to clean the boilers again. And Wood was therefore very interested in why the dams associated with railway stations were going salty. And in Wood's paper, you'll find this typical cross-section of a valley. We'd probably call those layers different things now, but it doesn't matter. To a substantial degree, we recognise that the profiles of most of our soils consist of very ancient soils, fairly deep-weathered profiles over rock. But Wood was really interested in these deep-rooted forests, and he correctly hypothesised that when that forest is cleared, there's a rise in the water table through the landscape, and where that water table is bringing salt to the soil surface. And where the water table gets to within about 1 to 2 metres of the soil surface, you get capillary rise of salt, and that is adversely affecting plant growth. And that is still our modern interpretation of the cause of salinity. And in fact, Bob Nelson's got a nice data set relating plant growth to the depth to the water table at a range of sites in the northern wheatbelt of Western Australia. I'm just going to show you, give you a sense of that data set. We've got depth to water table on the x-axis here, and plant cover class on the y-axis here. I'll explain what that means in a minute. And he had 3 sites where he had a cover of sea barley grass. There they are. And those 3 sites had depths to water table of 1.2 to about 1.6 metres. Here are the other cover classes that he used in this data set: wheat, barley, a mixture of sea barley grass and ryegrass, and then further down, patchy sea barley grass, and finally bare soil. And you can draw a line through that data set. It's highly significant. And I think what the data set shows us is something really important about how salinity responds to changes in the depth of water table. For example, if we had a 70 centimetre fall in the water table from about 1.5 metres there to about 2.2 metres here, we'd be in effect moving from a situation where we had sea barley grass to barley. And the reverse is also true. We had a patchy a piece of land which was just able to grow barley. We'd probably have a water table of around 2.2 metres, and if that water table then rose, became shallower, and got to about 1.5 metres, then we'd now only have a landscape which was suitable for the growth of sea barley grass. The other thing that Wood tells us is that the salt falls in the rain. He goes out and he actually measures the salt concentration in the rain in the catchments that he's studying, and he measures 3 to 8 grains per gallon, whatever a grain per gallon is. And that, we would still agree, is the major source of the salt that occurs in our landscape. He also says that it comes from the sea, and that's in fact also correct. Here's a data set that shows how we know that there is a relationship between the salinity of the rain and the distance from the coast. You can see in this graph that the salt concentration in the rain really increases as you get very close to the coast. But even at distances of 100 to 200 kilometres away, there's still a measurable amount of salt in the rain. And over long periods of time, that accumulates in the soil and builds up salt concentrations to concentrations up round a tonne per square metre. I don't think we get from Wood this sense that the rain occurs over long periods of time, and that salt accumulation in the soil profile occurs over tens of thousands of years. And I suppose that's the major difference between our modern interpretation and what Wood had to say. So, to just summarise all of that, I think that salt land is affected by increased salinity and waterlogging, and that both of these decrease plant growth. Devising solutions for salt land may well require a hydrological understanding, some knowledge of drainage and surface water management, the growth of better adapted plants, and an understanding of animal responses to salinity. But it must involve a really strong collaboration with people who are involved with salinity and who live with the problem all the time. I think some landscapes, especially in Western Australia, are acutely affected. And in all cases, I think our dryland salinity problem is caused by the development of a shallow water table. Okay, I hope you'll look at the other segments in this series. Thanks.